The problem is we have a flat disk, a circular disk with a circular hole which is tangential to the rim of the disk, and the radius of the hole is r by 2, where r is the radius of the full disk. And we have to locate the center of mass of this disk with a hole. Straight away you can see from symmetry that the center of mass of this remaining part of the disk after the hole has been removed lies along line joining the center of the original full disk and the center of the hole. So let us say this is the center of the full disk. Let's call this point O, and we'll make that the origin of our coordinate system, and let's call this the x-axis. When you want to find the center of mass, you will always need a coordinate system. Of course, the y-coordinate of the center of mass is going to be 0. Since most of the mass of the disk is on the left of the origin, we expect the center of mass to be somewhere there. Let's start by saying the mass per unit area of the disk is sigma. Right away I should tell you that the answer will not depend on sigma. Sigma should cancel out, because whether this disk with a hole is made of cardboard or brass or iron, it doesn't matter. The center of mass is going to be located at the same point. So now we have a full disk. Let me show you what the full disk looks like. This is the full disk. And to this full disk, what we are going to do is we are going to add a smaller disk of negative mass density minus sigma, so that plus sigma and minus sigma cancel out, leaving a hole. So the full disk has a mass of pi r squared sigma, and the small negative density disk has a mass of minus sigma times pi r by 2 the whole squared, so pi r squared by 4. So these are the two masses when added together, that is the full disk with all of this covered. To that, when I add a negative mass disk, it produces a hole. So we can think of two objects. The center of the full disk is of course O. So when we want to find the center of mass of this composite object consisting of the full disk, this, and the negative mass smaller disk, it's going to be m1x1 plus m2x2 by m1 plus m2. So it's going to be pi r squared sigma m1. Its x coordinate is here. The full disk has its center of mass at the origin, so x coordinate is 0, plus m2 is negative, minus sigma pi r squared by 4, and its x coordinate is at a distance of r by 2. This is m1x1 plus m2x2 divided by the total mass pi r squared sigma minus sigma times pi r squared by 4. This is the x coordinate of the center of mass. Very simple. Pi r squared sigma is common through the whole thing. Let's cancel it out. The first term is 0. So pi r squared sigma has gone. So I have r by 8 in the numerator with a minus sign, divided by, in the denominator, 1 minus 1 by 4, that is 3 by 4. So this becomes 4 goes above and cancels this, gives me minus r by 6. So the center of mass is located here at a distance of r by 6. That's it for this problem. Thank you.